Okay, so for the second hour of class, I want to go back through. We've done all these operations with numbers, but let's throw in what happens when we have numbers like that, negatives. Well, we first have to figure out what does that -4 mean. We talked briefly about representing numbers on the number line using those vectors. So -4 starts at 0 and goes to -4. Now the thing with it is the length of it is exactly the same as the length is +4 if I'd drawn the number lines correctly. The exact same length, it just points in the opposite direction. And that's really important when we go to work with them. So if I have something like 8 plus a -3. Now your textbook would usually do this. Put it in parentheses so it separates that negative. 8 plus a -3. Well, I have 8. Looks like that. Oops, careful. Trim that back. 8's going to look like that. -3 is going to look like that. When I go to combine them with the addition, I move that vector for the 3 over here. Come on. Try that again. And you'll notice what happens is that the arrows are pointing in opposite directions. Rather than building up to make a longer vector, they actually cancel out to make a shorter one. So the result here, we end up at 5. 8 plus a -3 is 5. Now if we have -7 plus 2, well, we have -7. +2 would just be like that. It's going to end up at -5. Now, I don't expect you to draw out these number lines every time you go to add negative numbers. Yes? Since it's in front, you don't necessarily have to. I mean, it's not wrong if you do. It'd be fine if you did. But this second one here, you almost have to. Otherwise, you got a plus and a negative there together. It's kind of confusing. If we have -3 plus 9. Again, I don't expect you're going to draw it out on the number line, but I keep that sketch in my mind. I've got here's 0. -3 goes that way. +9 goes the opposite direction. Is it longer or shorter? It's longer, right? So it goes past 0 into the positive. So that little sketch tells me two things. One, that this is a positive answer. Two, it's the difference between the length of these vectors. What's the difference between 3 and 9? 6. So even though we're adding, we end up having to subtract to get the answer. Or we might have 4 plus a -7. Again, I'm going to keep that picture in the back of my head. Here's 0. 4 goes this way. -7 goes the opposite way. Is it longer or shorter? Longer. 7's bigger than 4, so it goes this way. And so again, this tells me that my answer is negative in this case, and the difference between those lengths is 3, so it's a -3. Does that make sense? Or if I have -2 plus, bless you, -2 plus -9. Well, again, here's 0. -2 goes this way. -9 goes the same direction. So that tells me, first of all, again, my answer is negative, and 2 plus 9, they're building on each other. They're going the same direction, so 2 and 9 make 11. So we're dealing with adding negatives. Even though we are adding, sometimes we're going to be combining the values, adding the values. Sometimes we're going to be canceling the values or subtracting them, like over here. That little picture with the vectors helps me know whether I'm adding or subtracting. And it also, because if they're going in the same direction, we're adding. Opposite directions, we're subtracting. And it also helps me know whether the answer is going to be positive or negative. So that if we get into bigger numbers, like 238 plus a -121, still, here's 0. 238 is bigger, is positive, it goes that way. Negative 121 is negative, so it goes the opposite direction, but it's shorter, so it goes like this. So that tells me my answer is still positive and is the difference between 238 and 121. So it's 117, positive 117. Makes sense? The real confusion comes in the subtraction. So let's say we have 8 minus 3. This is looking at the positive numbers. If we were going to draw this out, we would do, there's 8 minus 3. Well, we know that comes back to 5, like that. Well, if we look at that picture looks an awful lot like the picture we would use for 8 plus a negative 3, doesn't it? In fact, it's the exact same picture because these are the exact same problem. We mentioned that subtraction and addition were the same operation. And that is very true, to the point where subtraction really isn't an operation on its own. The definition of subtraction, this symbol here, what we know as the subtraction symbol, means add the opposite. And by opposite, we mean positive or negative. So when we're looking at, when we see that where it says 8 minus 3, what that really means is 8 plus the opposite of 3 is negative 3. So if we see a negative 5 minus 2, what that really means is negative 5 plus, what's the opposite of 2? Negative 2. Subtracting a positive 2 is the same as adding a negative 2. So now that tells us, now that we've changed it to addition, we can go back to our arrows. Here's 0. Negative 5 goes that way. Negative 2 goes the same way. Our answer is negative. Do we add or subtract? The arrows go the same direction or the opposite directions? Same, so we're going to add. 5 and 2 make 7. So really, subtraction is addition. We just have to know how to convert it over. So if we have, the tricky one, of course, is this one. 5 minus a negative 3. That's going to become 5 plus, what's the opposite of negative 3? Positive 3. Minus a negative number is the same as plus a positive. 5 minus a negative 3 is really just 5 plus 3. It's 8. Exactly, double negative if you want to think of it that way. Or even negative 7 minus a negative 2. That's going to become negative 7 plus 2. So you've got negative 7, positive 2. They go opposite directions. Is this answer positive or negative? Negative, and it's going to be 5. Difference between 7 and 2 is 5. Negative 4 minus 9. What's that going to become? Does the negative 4 change? No. What changes, this becomes plus negative 9. That was minus a positive 9. It becomes plus a negative 9. So now we've got, here's 0. Here's negative 4. Negative 9 goes like that. So that means our answer is going to be positive or negative? Negative. Add or subtract. They both go the same direction, so we add. 4 and 9 make 13. So negative 13. What do you think? Good stuff? Better than a sharp stick in the eye? Okay. What's that? Oh. So that is subtraction. And it works with larger numbers as well. Then we could have a negative 541 minus 273. We would have to change that. Negative 541 plus a negative 273. So you get 541, I don't know where the one went. 541 negative 273, they go the same direction. So the answer is negative, and you just add them together to get 814. So it's a negative 814. What do you think? Anybody totally lost? It was okay? Multiplication. We've already looked at this here. 5 times 3 is really a repeated addition. 5 plus 5 plus 5 is 15. So then it's not much of a stretch to say negative 5 times 3 is negative 5 plus negative 5 plus negative 5. Now you'd probably have the parentheses in there like that. Well, that's going to be negative 15. How about 5 times negative 3? Oops. Can I take 5 and add it to itself negative 3 times? No. But what we can do is we can flip this around and say instead of 5 times negative 3, we can do negative 3 times 5. So that's times we're going to take negative 3 and add it 5 times. Or 5 negative 3s and add them together. So it is still negative 15. Well, we'll get there yet. Hang on there. You're getting ahead of us. So when we multiply, you can see 5 times 3, it's going to be 15 of some form no matter what. But when it's a negative times a positive, we ended up with a negative answer. Or a positive times a negative, we ended up with a negative answer. The only possibility that's left, what if this were negative 5 times a negative 3? Well, there's no way we can do this according to the definition of multiplication. We cannot take negative 5 3's and add them together, and we can't take negative 3 negative 5's and add them together. It's just not possible. But we've already been taught, what's the answer to that have to be? 15. Somewhere along the line, most of us were told that when you multiply two negatives, the answer has to be a positive. And it's true, but the question again, as always, is why? As I said, the definition of multiplication doesn't allow us to do that. We can't add something to itself a negative number of times, and there's no way to rearrange that so you're not trying to add something a negative number of times. So to get around that, what we do, and this happens a lot in math, where our definition the definition fails. It breaks down and doesn't work. So what we do is we look for a pattern. Math is really all about patterns. So let's start with that negative 5. If I multiply negative 5 times 3, what do I get? We already did this one. Negative 15, right? So what if I do negative 5 times 2? What do I get? Negative 10. Negative 5 times 1. Negative 5. So let's look at what's going on here. When I start with a negative 5 every time, if I reduce what I'm multiplying by 1, my answer goes up by 5. So if I keep going here, I still start with a negative 5. I'm going to reduce this by 1 to 0. What's negative 5 times 0? Well, anything times 0 is 0, right? The answer went up by 5 again. So the pattern holds. So if we keep going now, negative 5 times negative 1, we'll reduce this by 1, so this has to go up by 5. That's got to be a positive 5. Negative 5 times negative 2, it has to go up by 5 more, it would be 10. Negative 5 times negative 3 has to go up by 5 more, or 15. What do you think? So when you multiply a negative times another negative, the answer is positive. And the reason for it is because it continues our pattern. So if I have a negative 7 times 9, what do I get? Well, first of all, is the answer going to be positive or negative? Negative. There's one of each, one positive, one negative. So when we multiply, that means we're going to get a negative. What's 7 times 9? 63. Close. How about 5 times negative 11? Well, first of all, positive or negative. Careful. There's one of each, one positive, one negative, so it's going to be negative. 5 times 11 is 55. How about negative 4 times negative 12? Positive or negative? That'll be positive. 4 times 12 is 48. So that's a positive 48. So the multiplication is fairly simple. Division is just as simple. If you look at the definition of division. 48 divided by 3 is 16. The definition of division, just like subtraction was defined as part of addition, division is defined as part of multiplication. It is saying 48 divided by 3 is saying what number times 3 equals 48. Well, 16 would be that number, correct? So if I have a negative 36 divided by 9, that's asking us what number times 9 equals negative 36. Well, first of all, this is negative, which means this one has to be negative, because a negative times a positive will give us a negative, and that would just be 4. Well, you can see here, 36 divided by 9 we know is 4. Negative divided by a positive is going to be a negative, just like with multiplication. What if we have a positive divided by a negative? That's saying blank times a negative 7 equals 21. Well, for this here to be positive, if this is negative, this one must also be negative, right? Because a negative times a negative makes a positive. So that would be negative 3. 21 divided by 7 is 3. Positive divided by negative is negative, just like with multiplication. And of course, negative 32 divided by a negative 4. Anybody want to venture a guess? First of all, what's 32 divided by 4? 8. A negative divided by negative, anybody want to guess? Is positive. Good. So those are the rules for negatives. That's how we work with negatives. Now, if you get the TI-30 calculator, there will be a little button. Should be close to the equal sign down here. That button will look like this. I'll draw it out bigger. That's the button you'd use to enter negatives. So to punch in like negative 32, you'd hit that key, and 32 divided by then the negative key again, 4 equals, and it will give you a positive 8. Do not use the minus, because you'll have the plus, minus, multiply, divide here. Don't use the subtract key. That'll make problems if you try to do that. Okay, so the last thing we want to cover today is what happens when we run into problems like this. Well, when we look at a problem like that, different people might decide to do things differently. They might look at that and say, you know what, I can add and subtract first. 8 plus 3 is 11. 7 minus 2 is 5. And 11 times 5 is 55. And that makes perfect sense. The only problem is that's not the right answer. In math, when two people do the same problem, we'd like to have them get the same answer. To make that happen, what we do is we define something called the order of operations. Order of operations are 4 levels. They're not necessarily steps. They are levels of telling us what is higher priority and lower priority. As we go through the problems, we always have to look at the highest level first. Our first level is something called enclosing symbols. Many of you are taught parentheses, but there are other types of enclosing symbols other than parentheses. Yeah. Well, there's others that we'll look at too. Second is exponents. Exponents are simply what we looked at as the powers and roots. Third level is multiplication or division. They're the same operations, so they happen at the same time. And the fourth level, the last thing, is to add and subtract. So, looking back at this problem. First thing that needs to be done, are there any enclosing symbols? No. Exponents? Nope. Multiplication or division? Yes, there is, right here. So we have to do that. We're going to take out those two numbers. We're going to combine them with multiplication. 7 times 3 is 21. The rest of the problem is unchanged. So now all that's left is addition and subtraction. Those are on that last or fourth level. But there's an addition and a subtraction. Since they're on the same level, we go left to right, just like reading a book. So we're on the left first. 8 plus 21 is 29. And minus the 2 is 27. Let's look at one that's a little bit more complicated. Oh, yeah. It's not as bad as it looks. I know that one looks kind of ugly, but it's not as bad as it looks. On a test or a quiz, I wouldn't ask anything quite that long, but...
Just imagine variables stuck in there.
Don't scare them yet, Cody. I've got to wait till their check's clear before I do that. If they drop now, they can still get a refund. I'm just kidding. This class, it looks ugly, but it's not as tough as it looks. We just have to follow our steps. First step, step 1, level 1, enclosing symbols. Well, there's a couple of different parentheses in here. When there's something on the same level, we always go left to right. So going left to right, first parenthesis we see is right here. Now we have to find its partner, its other end. Is this it? No, that's going the wrong way, isn't it? How about this one? That's going the right way, but that partners with this one. We're going to go all the way to here. We found its partner. Now some of you might be thinking, but we got to do the inside one first. Well, just hold on. Now that we've identified that enclosing symbol, that's where we start. But the order of operations still applies in there. We're still at level 1. Are there any other enclosing symbols in there? You bet. There's another set of parentheses. So we got to move inside that set now. Now in there, are there any other enclosing symbols? No, there are not. So then the next level, exponents, powers or roots. There's just one, there's the 3 squared, which is going 3 to the power of 2 is 9. So I replace the 3 to the power of 2 with 9, and everything else in the problem stays exactly the same. Now, I will warn you to be careful, because the biggest mistake I see on most people's problems is rewriting the rest of the problem. They properly combine the two numbers, then they don't rewrite the rest of the problem, or they make a mistake rewriting it. We're still inside the parentheses here. Any more exponents? Any more powers or roots? No. Next level, multiplication or division. You bet. Division. 18 divided by 9 is 2. So I replace that with a 2. The rest of the problem does not change. Next. Still in the parentheses, 6 plus 2 is 8, right? That's all that's left to do. Now that we've reduced what's in that parentheses to a single number, we don't need the parentheses anymore. But before I take out the parentheses, I have to double check. Is there anything that needs to be done to the parentheses? And in this case, there isn't. There's a symbol on both sides, so we're good. So I'm just going to rewrite everything else with the parentheses now out, because like I said, once it's reduced to a single number, we don't need the parentheses anymore. I almost just did it myself there, made a mistake writing down the rest of the problem. So now that we're done with that set of parentheses, we move back out to this other set. Are there any other enclosing symbols in there? No. Any other powers or roots? Yes, there's 4 squared, which is going to be 16. So we replace the 4 to the power of 2 with 16. Plus 2 times 5. Everything else stays the same. Any other powers or roots? Not in the parentheses, at least. Next, multiplication or division?
Yep.
You bet. And again, since there's more than one, we go left to right. So the first one is the 16 times 3, which is 48. Everything else stays the same. Next would be 2 times 5, which is 10. It is. Normally what I do, especially since I can erase really easily on here, is I just write out the problem and I erase and replace pieces. But I realize in your notes you need to see the steps, so you're going to have to write it out. Now, we're still working inside the parentheses here. Are there any more multiplication or division? No. So all we have left is addition and subtraction. So we're going to go left to right. 17 minus 48 is a negative 31. What's next inside there? Negative 31 plus 8 is a negative 23. They go negative 31 plus 8. They go opposite directions. It stays on the negative side. Difference between 31 and 8 is 23, so it's a negative 23. We're at minus 3 plus 10. What's next? Negative 23 minus 3, that becomes negative 23 plus a negative 3. So negative 23, negative 3, they go the same direction, so it's going to be negative 26. Good. Next. All we've got left is the negative 26 plus 10. Negative 26, positive 10, tells us that's going to be negative, and it's the difference between them is 16. Now I've reduced everything in those parentheses to a single number, so we don't need the parentheses anymore as an enclosing symbol. But we do still need them as separating that minus, so it's a negative. Normally, if we took out the parentheses, since there's a 2 in front of it here, what operation does that imply? Multiplication. So if that was a positive number and we could take out those parentheses, we'd have to remember to put that multiplication in there. So now, even though there are parentheses there, it's no longer an enclosing symbol. It's not separating part of the problem. It's just attaching that negative to the 16. You can get going if you need to. We'll see you tomorrow. So now, multiplication is the highest priority. There's no more enclosing symbols, no more exponents. 2 times negative 16 is a negative 32. So this is 8 plus a negative 32 plus 1. 8 plus negative 32 is a negative 24. Plus 1 is a negative 23. Now that took a lot of paper and a lot of space and a little bit of time. But as long as you go through the steps, it's not bad.
All that obviously 23.
Or negative 23 for that matter. Let's do another example. Let me sure I do this right. So here we go. Looking at this, to make this one work, we need, first of all, to define what this thing is here. Okay, it does mean division. It's called a fraction bar, and it does mean we're going to divide. But it's also an enclosing symbol. It separates part of the problem from another part. It's telling us that we're going to do everything on top first. Then we're going to do everything on bottom. And then we're going to divide. So it's another form of enclosing symbol. So on top, do we have any other enclosing symbols on top? No. Any exponents? Yes, we do. 8 squared is 64. Any other exponents? No. Multiplication or division? Yes. 26 divided by 2 is 13. 64 minus 13 is 51. On bottom, do we have any enclosing symbols? Yes, we do. Parentheses here. In those parentheses, do you have any other enclosing symbols? No. Exponents? Yes. 4 squared is 16. Still have to go inside the parentheses. 3 plus 16 is 19. It's down to a single number, so I don't need the parentheses anymore. Any more enclosing symbols on bottom? Nope. Exponents? Multiplication or division? 4 times 9 is 36 minus 19, which is 36. 36 minus 19 is 17. So on top we had 51, on bottom we had 17. Now we can divide. 51 divided by 17 is 3. So the answer is 3. What's that? Kind of, yes. On my math lab, homework 1 is due on Monday, basically at the start of class. Tomorrow we'll have time to ask questions on homework 1. Try to help you with anything if you're having problems registering for my math lab. Otherwise, tomorrow we're going to go over, review some stuff, kind of maybe get a head start on Monday, or hopefully you guys get a start on the homework and have homework questions for me.